Um, all right, where do we start here? I want to keep this just really basic. Believe it or not, some of this will you may think isn't basic, but there's just a couple of I guess key parts to using R that we're gonna talk about here in this video. First thing, obviously you have to have it installed, and I've already uploaded a video that let me get my hand out of the way there. Now I've already uploaded a video that showed you how to install R. So if you don't have R installed yet, you need to pause this video and get that done. But the very first thing that we have to do is we have to learn to enter data. And I'm going to show you two different ways. There is a kind of a C function that that we learn to use, and then there are ways that we can actually upload a file. And I'm actually going to go over that here too. Now, guys, if you'll go to, let me get out of here and go to your Blackboard site. If you go to Blackboard and look at week 3, September 7th, I've uploaded a couple of things. Probably more than likely you've watched recently the video on statistically describing categorical variables. So those are the handouts. But there's a handout right here called Body Fat Data Set. Okay. Now, I'm going to click that, and it's going to download it. And I'm going to click this down here to open up the file. And looks like I've got some updating to do, but I'll do that later. Now, guys, I'm going to make this larger so everyone can see it. And I'm going to go with full screen just because I want to. All right, now, if I were going to enter these data and work with the calculator, then here's, I'll tell you what I want to do. I'm going to regroup here. Let me exit full screen, and what I want to do is exit full screen here too. And all right, so what I want to do right now is I just want to focus on these tricep measures, and it looks like there's 20 of them. So if I were going to work on this with the calculator, what I would do is, just as I've shown you in previous videos, I would go to Stat, and I would go to Edit, and I see that I've got data in there I want to get rid of, so I'll go up and hit L1, and I go Clear Enter. So that wipes out the list without, well, I should say it wipes out the entries in the list. So, I'm going to type these in. I probably should have already had this done, but I don't. So 19.5, 24.7, 30.7, 29.8, 19.1, 25.6, 31.4, 27.9, 22.1, 25.5, 31.1, 30.4, 18.7, 19.7, 14.6, 29.5, 27.7, 30.2, 22.7. This is boring the snot out of me. All right, and 25.2. Now I know I need 20 numbers, so I'm going to go back and highlight the last number, and I can see that this number right here is going to tell me my sample size, which is 20, which corresponds. Now, it doesn't necessarily tell me that my numbers are correct. I could have done a typo, so I always like to start at the bottom, just go back up and spot check. because it's really frustrating in statistics to know what you're doing and make a typo and get the answers wrong just because you made a typo. And guys, we all do it. So it's going to take us about 30 seconds. I think all of you have an additional 30 seconds if you're being honest. So guys, it looks like to me that we've got, at least I've got the list in correctly. So I'm going to make this larger. So now if I want to go through and find the basic descriptive statistics, and again, well, let me go back to our data set. What I have here is I have tricep measurements. Okay, so I can find the average tricep, the medium tricep. So let's just find those things. So guys, remember to do that. We go to Stat. We go over to Edit. We go to One Variable Stats. And this operating system, I would go One Variable Stats 01. We don't have a frequency distribution, so I don't do any of that. And I could see that the average tricep measure for these 20 participants, subjects, whatever it may be, is 25.31. The standard deviation would be 5.02. The sample size is 20. And I can scroll on down and get the 5-number summary. So the 5-number summary here is 14.6, 20.9, 25.5, 30, and 31.4. So guys, I want to write that down because I want to point something out in just a second. So the 5-number summary here is the minimum value is 14.6. Q1 is 20.9. The median is 25.55. Q3 is 30. And the maximum value is 31.4. Now, we've already talked about this a little bit, but if we wanted to do a box plot for this, what we could do, the box plot is just a picture of our data of the 5-number summary. So what I could do is I could see that my values run from 14.6 to 31. So what I would probably do is I would probably run this from 10 to 40 for obvious reasons. I want to have enough range to include all my data. So 14.6 is going to be about right there. 20.9 is going to be about right there. 25.5 is going to be about right there. 30 is going to be approximately there. And 31.4 we're going to say is about like that. Now box plot, we take the inner 3, create the box. Sometimes you hear these things called box and whiskers. Those are the whiskers. So the box plot tells me, gives me a picture of the variation from the lower 25% to the next 25%, to the next 25%, to the next 25%. If there was an outlier, there would be an asterisk or a dot or a circle or something, out here to represent that. But of course, we don't have that here, so that doesn't apply. Okay, so keep this in mind because R is going to do some crazy stuff here in just a second. Okay, so we'll go back and get that in just a second. Okay. Now, first thing we got to do is we got to work with this data set right here. And what I want you to do is I want you to get accustomed to saving these data sets on your desktop. So once I've downloaded this thing, I've got it in Excel format, so I'm going to go up and do a Save As. Now, I need to save this as something just one word. I don't want that parentheses 1. I want it as something, just one word, very simple. I usually don't even, when I do a save as a name, I usually like to have it 3 or 4 letters. I've exceeded that here and made 7, but the body fat is fine, okay? The where part, I want that to go to my desktop. And the format, I want it to be CSV. Now guys, you gotta be careful here. There's another .csv, like right down here, the MS-DOS, comma separated value. If you want to drive yourself insane and get this into R and not work, and you understand, you feel like you've done everything right, but you don't understand why you're getting an error, if you want that to happen to you, choose one of these 2. It's not going to work. You have to choose the one that says comma separated values.csv only. Don't choose the one that says MS-DOS. Don't choose the one that says Windows. Choose the one again, comma separated values only. And you can scroll up and down to get this. Now I'm going to hit save. And it's going to say there's going to be some features that may be wacky or whatever. Just ignore that and go continue. And now when I go to my desktop, you're going to see, let me get rid of this. You're going to see that I have right here that I'm circling, I have a file by the name of body fat. Now, what I want to do now is I want to bring up R. I've already got it saved to my machine. So I'm going to click it, and this is what it looks like. Now, the first thing I want to do is I want to show you how the C function works. The C function is one way to put in data if you are, let me get this where, if you just have a small data set, only one variable, then this works fine. So what I'm going to do first of all is I'm going to name it something. And I'm just going to call this triceps. Do the less than. Do the arrow. And this is going to use what's called the C function, which allows me to put in a bunch of numbers and save it as triceps. So I have 19.5, 24.7, 30.7, 29.8, 19.1, 25.6, 31.4, 27.9, 22.1, 25.5, 31.1. Huh. Okay, there we go. 30.4, 18.7, 19.7. Now guys, I'm going to make a mistake here. I'm going to go 14.6 point. Now that should be a comma, but I'm going to do that just to show you what happens if you do make a mistake and how you take care of that. So 29.5, 27.7, 30.2, 22.7, comma, and 25.2. Now when I hit that, it's going to give me an error. And the error is something I just have to go through and try to figure out, why is there an error. And I had a student about a year ago who R drove her crazy. She just did not want to pay attention to detail. So if something happened like this, even though it shows you right there where the error is, she would completely flip out. Now the beauty of it is once you're there, you don't have to go back and retype all of that. What you can do is just hit your up arrow and it will bring everything from the previous line down so you can edit it. So I have to take, a couple of minutes. Then I have to come in here and find out that, well, that should have been a comma instead of a period. So now I'm going to hit enter and notice nothing happens, and that's good. When you do R, when you implement a a command in R and it's working correctly, you don't get any red stuff. You don't get any bells and whistles. You don't get any well done. You don't get any awesome jobs, any prompts like that. You just get a completed entry, and that's good. Now, once I've got the data in, I can find things that we found with our calculator. Now let's go through and find some of those. Okay. Now I'm going to bring my calculator up just to show you how we find the corresponding numbers with R. Okay. All right. Now, before, if I want to find the numbers, I just go to stat, go over to calc, one variable stats, L1. So I'm using, I don't have the information in here, do I? No, I don't. Shoot, I'll tell you what, let's do. I've got it in the other calculator. So let's just bring this up. All right, this works fine. So to find, for example, the information we had before, to find the mean, for example, over in R, all we have to do is just type mean triceps, and you'll see that we get 25.305, just exactly like we did with the calculator. Now, the question may be, well, how did I know you're supposed to type mean to get that? Well, guys, that's my job. I teach you how to do this. I expect you to know absolutely nothing. But what I expect, well, I expect you to know something, but I expect you to know absolutely nothing regarding R. All I expect you to be able to do is to organize your life, and in your notes, remember the Cornell note-taking thing that you guys are required to do for each one? I expect you to write this down. So the next time you bring up a data set and you need to find the mean, you can go to your notes and say, hey, all I got to do is just type mean, and it does the trick. Now the next thing we get over here is we get the standard deviation. Well, guys, to get the standard deviation, it's just SD. And you'll see we get exactly the same thing. The next thing we get on the calculator is N. Well, guys, to get N, you do length. So the sample size is found by typing length and the variable name. So we've named the variable triceps here because, appropriately, I may add. So we have a length of 20. Now, things get a little bit more complicated when we get down here. The minimum value is easy to find. It's just 14.6. We just do min triceps, and as you would expect, we can do max triceps and get the biggest value. Now, to find the range, which is the high minus the low, we could just type 31.4 minus 14.6, and we could get the range of 16.8, I guess what we call physically, just by typing it. Or what you can do, if you don't like that, you can type range of triceps. Now, it's not going to give you the range, but it's going to give you the two numbers that you need to create, or I'm sorry, that you need to subtract from each other, 14.6 and 31.4, to get the range. Now, I wish it just spit it out, but you have to do a little typing. And this screen on R, if you want 31.2 and you want to square that, I mean, it's got a calculator kind of built into it. But we traditionally, or typically in this class, we're going to use R for statistics stuff. So if we want to do something in like 31.2 squared, I'll use my calculator. But you don't have to. You can use it over here. The next thing we would do is Q1. Now, this is where things get tricky. The function for or I'm sorry, the command for quartiles is called quantile. And we get quantile triceps. Now, this is not going to be fun. Now, I'll tell you what, let me back up a little bit. Before we get into that, let's go ahead and get the median. And you'll see the median is 25.5. So, you know, that was easy to get. So, again, we're just bouncing through here. Min's easy, max is easy, median's easy, length is easy, sample size is easy, standard deviation, mean that we saw previously. But now when we get into quartiles, Q1 and Q3, things get a little different. Okay? Now, first of all, if I'm going to get the quartile here, I'm going to have to take 30 minus 20.9. If I get the IQR, I take the Q3 minus the Q1, so 30 minus 20.9 is 9.1. Now, when I go IQR over here, I get 8.4. Now, that's not cool, is it? But welcome to statistics. It's not that the IQR is different. It's still, there's no mistake. It's just a different way of calculating the quartiles. Now, again, guys, this is just something we got to live with. I know that students like things to be black and white. They don't want different answers. But that's when you're doing publications, when you're publishing things or doing studies like the occupational therapy grant I just finished. The very first sentence or at least one of the first, it was in the first paragraph, is I told the reader what statistical software I was using. Because people who are in statistics community, we realize that things like this happen. So, and I'm going to illustrate to you just a second why this works this way. Okay? Now, how do we get the answer on R to correspond with the graphing calculator? Well, there's something called a quantile, and I can do this of triceps, and what this will do is it'll give us the 5-number summary. Now, when we go over here to the 5-number summary, you can see that the 14.6 lines up, the 25.5 doesn't. I'm sorry, we're up here at 14.6. The 21.5 doesn't. The 25.5 does. The 30 doesn't, but the 31.4 does. So the only two numbers over here, the 20.9 and 30, that doesn't correspond over here to the 21.5 and the 29.9, it's the reason the way R has calculated things. Now, what we can do is we can adjust this. So if we go quantile triceps and go type equal 1, notice how things have changed. They still haven't changed to where it aligns with what we get on the calculator. But if I go up and go type equal 2, notice that it does align perfectly. So, guys, long story short, if I calculate my IQR based on the 21.5 and 29.0, I get 8.4, which is the default for this up here, but it doesn't align with what the calculator does. If I calculate the IQR based on type 1, then I'm going to take 29.8 and I get 10.1. Again, not what we get over there. But if I type equal 2 here, then I take 30 minus 20.9 and I get 9.1, which aligns with what the calculator gives me. So guys, to get things to equal up here, what I want you to do is always type, when you do your quartiles, always use type 2, and you calculate your IQR from there. That way we'll be consistent over here, okay? Now, why does this work this way? Let me show you why it works like that. Let's take some numbers. And let's just call these numbers X. And let's take 15, 32, 38, 43, 67, 72, 79, let's see, 1, 2, 3, 4, 5, 6, 7, and let's go 90. Now, one way of calculating the median would be to come to the center. Well, actually, both ways. And I want to make, yeah, okay. So we would come to the center, and we would see that there isn't a number that's distinctly in the center. So to find the median, we would average 43 and 67. And when we do that, we get a median of 55. Now, in calculating Q1, what do we do with these numbers right here? Should we use just the numbers below the value that was used to calculate the 55, the median? Or should we use all of the numbers below the median, which includes the 43? Well, it depends, and R calculates it both ways. R will calculate just using using all the numbers that are below the median from 43, or it will use the numbers below the number that was included or used to calculate the median. Now, if that's just too much for the brain, guys, the best thing to do is just remember that anytime I want to calculate, and I'll tell you what, let me go through an illustration. I think this is actually going to be worthwhile to do this. Let's go 10, 20, 25, 28, 32, 38, and 50. All right, so this will be a good illustration. So keep it simple, without question. The median is 28, right? One approach to calculating Q1 would be to take 10, 20, 25, and 28, so include the median. These two numbers are distinctly in the center. Call Q1 22.5. Another approach of calculating Q1 would be to take only the numbers below the median. In this case, we have distinctly a number smack dab in the center, which is 20. So let's go over here and see how this works in R. So I'm going to have X, and I'm just going to type in these numbers. So 10, 20, 25, 28, 32, 38, and 50. So if I just do quantile of X, then I get 22.5 as Q1, which is what we had over here. But if I do quantile X type equal 2, then I get 10, 20, and 38. I get the 20 as it calculates right here. So again, guys, this is just a very simple very simple illustration over here with a nice compact data set that shows you that the value for Q1 and Q3 will change depending on the way that they have used to calculate. In other words, did they include the median or fail to include the median in locating the position of Q1. And it'll be the same thing with Q3, okay? Did they include the median? So, guys, let's just all be consistent. That'd probably be a good test question. How do you handle R to make the R output give you the same quartiles as the graphing calculator? all you can do is just add type equal to after the quantile feature. Let me show you a little bit more. Let's go back to this tricep measure. Histogram, really easy. It is if you do it right. Okay, what's going on here? Okay, there we go. This is worth going back. What did I do wrong? I started second guessing myself. I knew HIS was, well, I didn't know, but I thought it was the right command in R to get a histogram, but I put in tricep instead of triceps. Now you and I see that as the same thing. R sees that as Venus and Mars. Completely different. And I started second guessing myself and came down here and did some stupid stuff. So, but guys, to get a histogram, it's easy. Just type HIST. So we have a slightly negatively skewed distribution here. Notice again the bars touch because it's not a bar chart. If we want to get a box plot to see if there are any outliers, we can get a box plot this way. So it'll give you a vertical box plot. I think you can actually change that. I believe. Apparently you can't. I thought you could. Okay, well there is a way to change it to a horizontal box plot. So, that's it's easy to find if we actually needed to do that. All right, gang. Let's talk about something else. What I want to do, I've got some clutter here. I want to get rid of this, and I want to bring it back up because I want to start with a new R. Start fresh. Now, what I want to do is I want to show you how to get data into R. For example, this body fat file that we saved quite a while ago. How do we get that into R? Well, here's how we do that. First thing we have to do is we have to do what's called set your working directory. Now, in case the Kentucky accent's a little too strong for you, we have to set our working directory. Now, the first thing we got to do is we've got to find where R has set our working directory. Now, our working directory is where we're going to naturally go look for files when we want to bring information into R. So what I'm going to do over here is I'm going to go get working directory, open parentheses, close parentheses, and hit enter, and it's going to tell me where it looks for a data set that I'm trying to input into R. Well, I don't know where this users/ddarbro is, so I'm going to set my working directory. So guys, we have to go set left parentheses, quotations. Now I can use that as a start, but I always want to set this as my desktop because desktop is an easy place to put your files, and it's the easiest working directory to change your default to. Now, if everything went well there, you get no red, you get no error. Set working directory, nothing happened, means it was implemented correctly. Now I can go to get working directory, and it'll tell me that it's going to go to my desktop to get the data, or to get my file. Now the next thing I want to do is I want to input my data from the desktop. So I'm just going to be creative here and call my data set data. Okay. And I'm going to go use what's called read.csv. And this is the reason that I wanted to keep the name of my data set something really, really, really simple. I don't want any spaces. I want everything to be, 3, 4, 5, 6, 7 letters. No spaces. It's easy to type in, and I put the .csv because that's the way we saved our file. All right, hit return. We now have our data set entered from the Excel format that we transferred over to .csv format. We've imported it into R, so now we've got it, right? Well, sort of. If I want to find, for example, the mean of triceps, it's not going to give it to me. And the reason it's not going to give it to me is that R hasn't yet recognized this data set. The only thing that we've done so far is we've just read it into R, but we're not yet ready to start working with it until we call attach it. So when we attach our data, it has now not only taken the data set that we call data that's sort of superficially in R, it has attached it to data where we can now perform statistical functions on the data set. So now guys, again, use the up arrow, the mean triceps. It's now going to give it to me. Standard deviation of triceps. It's going to give it to me. Now guys, something really, really, really important to remember. And this is something that happens to students a lot, and it drives them crazy. The variables, well, data, actually, we typed it in data. This represents our entire data set. I've had people before go mean of data. That makes no sense whatsoever. In fact, let me show you what happens when you do that. It makes no sense because the data that we're looking at here over in R is all this stuff. It's the subject number, it's the tricep, it's the thigh, it's the midarm, it's the body fat. It's all of these things together. So if I go mean data, R is going to think I'm crazy because it's like, mean of what? I don't even know what you're talking about because data is this overall name that represents the subject number, the triceps, the thigh, the midarm, the body fat, everything together. So guys, back to this, remember our data set, I think I've includes what? It includes the cases, and up and down it includes the variables. We can only find the mean of a variable. We can't find the mean of a data set. We can't find the mean of a case. So I find the mean of, for example, maybe I want to find it of thigh. Well, that'll work. Maybe I want to find the mean of midarm. Well, that'll work. But mean of data makes no sense because data is everything put into our data set divided across the variables that we have. So the variables that we have here are subject number, triceps, thigh, midarm, and body fat. These are our cases. This is case number 1. Case number 1, we have that information on one person. Down here 13, we have that information on the 13th person. Right down here on the 19th person, we have that information. But we read in statistics up and down. You can tell somebody that knows squat nothing about statistics. If you give them a data set, they will read left to right. They'll come in and say, well, there's Susie. She's number 12. She has a tricep of 30.4, thighs of 56.7, midarm of 28.3, and a body fat of 27.2. That's where the juicy gossip is. That's where the information is about that person. Statisticians could care less. We read up and down. Let's examine triceps. What's the mean? What's the standard deviation? What's the IQR? What are the quartiles? What's the distribution shape? What are the outliers, if there are any? We care about triceps. We care about examining variables. We could care less about cases unless one of them turns out to be exceptionally high or exceptionally low, and they're an outlier, so we may want to examine the appropriateness of including them in our data set. Okay? So guys, again, let's just focus on body fat. Now, something I can do, if I go hashtag or number sign, this is something that I can type in and say, communicate between you and me. Now, if I would just happen to not start that with a hashtag, as we said, it's looking for more. And it's like, I don't have anything else. Well, you got to give me something else. Guys, to do that, we need to come in right parentheses, and it's still not going to, so we'd have to hit escape. Yeah. To keep that from happening, if you want to communicate to me, you're going to turn something in, and you're going to want to say, okay, Dr. Darbro, now I'm getting ready to run a test of hypothesis. Well, start it with a hashtag. Otherwise, R is thinking that you're putting in some weird statistical command, and it has no idea what let's focus on body actually means. But anyway, let's focus on body fat. Now, before I get into that, one thing you can do to get your variables is called names. So I can go names of data, and you can see that you have 1, 2, 3, 4, 5 variables. All right. So again, let's focus on body fat. The mean is 20.195. Standard deviation 5.11. The median 21.2. How many people have body fats? 20. The range is 15.5. The IQR, according to one calculation method, is 7.23. According to the calculation method that your graphing calculator uses, it's 8.35. So guys, I hope this is clear. You're going to have some assignments where we use R. I think it's important when you come out of a class like this that you understand how to use a statistical software package. I'm not going to ask you to do anything creative, anything where you create something new. All I'm going to ask you to do is repeat things that I teach you, that I show you. So guys, the key to that is to keep good notes, because if I give you an assignment on R and I give you this huge data set, maybe it's got 500 cases, well, you can't go through and type 500 numbers in your graphing calculator. You want to be able to input this into your graphing or into R very quickly, type mean of the variable. Let's just do thigh here, and you very quickly get the mean. Okay, so so you don't want to say, well, Dr. Darbo covered that in a video, and you log on, you go back to Blackboard, you search through the videos and try to find which one that I did this in. Write it in your notes, and then you just thumb through your notebook and you say, oh, here's the video where he did R. How did I find the mean? Well, you just type mean the variable name, and you've got your answer very quickly. So, guys, part of the, some people just don't want to be organized. Some people just like my daughter does, love her dearly, but she just loves randomness, scattered. She loves it when her clothes are thrown everywhere in her room. She hates it when she has to sit down and think real critically and organize her thoughts. She just doesn't like that. And the crazy thing about it is she's so smart she can get away with some of it. Some people just don't like it. But guys, to be successful at this, you kind of got to play that game. So, you know what? I think I'm done. I think I've got everything done that I wanted to get done. So let's end this video. Take care. No, I'll tell you what. One more thing. Box plot. I wanted to focus on body fat. So no outliers, and then histogram. What does the distribution shape look like? Well, we call that bell-shaped and symmetric. All right, guys, take care.